All right. Hi, everyone, again. I promise this is the last time you'll have to hear me today. So this time, instead of talking about security, we're going to talk a bit about C and C++. How many people do have C and C++ in their applications? It's OK. We won't judge you. A lot. OK. How many people have purely C and C++ applications? No Ada. We will judge you. No, that's fine. The reason that we want to talk about this is we know that you have C and C++. We're not dumb. We know that you have stuff other than Ada, and that's OK. Sometimes C and C++ is the best thing for the application you're working on. Sometimes usually it's Ada, but sometimes C and C++ have their points. So we want to kind of give you an idea of what we have to offer you from the C and C++ point of view. Even though our name is AdaCore, we also do C and C++. So why AdaCore and C and C++? Well, all those applications that have Ada, C, and C++, they're all running on probably the same operating system or on bare metal. They're all getting linked together. They're all getting put on one system. So ideally you have something like this. Sometimes you have to do something like that. Perfectly fine. So how do you do that? Well, the technology works like, and sometimes you have to do that. The technology works like this, where you have the compiler front ends. You write your code C, C++, and Ada. There's a similar back end. In this case, it's GCC. And that generates your binary. That's great. Everything works together. Now, you might be thinking, well, yeah, OK, we have the Ada compiler from you guys, but I have a C and C++ compiler from my OS vendor. OK, let's see what happens if you do that. Oh, yeah, the reason this works is, again, all based on GCC. So let's say you have this. You already have a C and C++ compiler from your OS vendor, let's say. You have an Ada compiler from us. You want to compile your C and C++, compile your Ada, link it all together, put it into a binary. What happens if version X of GCC and version Y are different there? Has anyone run into this? I see one person. Do you get something like, OK, so this one's provided by the OS RTOS. I guarantee you version X is going to be an older version of GCC, whereas this version is going to be a newer version coming from us. What happens when you try to link these together? Why is that a problem? Well, unfortunately, with GCC, they end up changing the C++ ABI pretty often. If you try and link these things together, it might work. Or you might get 300+ errors or something that looks like undefined reference to yada, 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 which takes forever to track down. So ideally, you want to be using the same GCC versions across all your different compilers. Well, what if you just have C and C++? Why would you still want to use AdaCore tools? Well, if you're getting your C and C++ tools from your OS vendor is precisely an OS vendor. They're very good at being an OS vendor. When you have questions about the compiler, let's say you want to ask your OS vendor, how do I do this in GCC? Will you ever get a response to that question? Now, if you have a compiler question, come ask compiler experts. And that's what we are. We are compiler experts. So when you do need support on a compiler, ideally, you should be coming to us and asking us questions. This is what we provide in the C and C++ realm. We do keep GCC up to date. We can provide that GCC matching between Ada and C, but we can also help you out with your compiler questions. Now, who here has used AdaCore support before? If anyone hasn't used AdaCore support before, go talk to one of those people that raised their hand. Ask them what they thought. Don't ask us. We're biased. We're going to tell you it's the best thing ever. Go talk to someone else who has used AdaCore support and ask them what they think of it. And then compare that to the support you get from your RTOS vendor. And then think about those two things. When you have a question, especially a blocking issue, and you go to your RTOS vendor and you're not guaranteed a response within days or even weeks, where this is a blocking problem, wouldn't you rather have a guaranteed answer within 2 business days? So this is why we think coming to AdaCore for all your compiler needs is going to be in your best interest. We can also provide things like updated language support. So if anyone's doing C++, we do have support for C++ 17, and I know a lot of RTOSs out there do not have C++ 11 yet. So we will keep all this stuff up to date as C++ 20 comes out, as C, I don't think they're coming up with a new version of C anytime soon, but maybe. These will continue moving forward. The other great thing is all the platform support that we have. Now again, you're going to get some things from your RTOS vendor, but ideally we should have comparable platforms. Now, Arno mentioned some of these earlier. The ones that are obvious, we have all the native Linux and Windows stuff. The cool ones are the cross stuff. And anything you see with this little symbol there is something we're working on. I noticed before a lot of people said they were using VxWorks. And I know a lot of VxWorks applications have Ada, C, and C++. So, and I know that actually one of those issues I saw earlier about having the std library errors and things like that, that may have been from a VxWorks application. So trying to combine those three languages in VxWorks is complex. So if you're able to get all of the compiler support from one vendor, it'll be in your best interest. You'll spend a lot less time trying to debug weird GCC problems. The embedded platforms here also are, as you're moving from, let's say, legacy PowerPC platforms with VxWorks 5, and you're looking at things like ARM or x86 or RISC-V, these are all things that we're supporting. We're trying to stay as comparable to what's at the edge of the market so that when you're ready to move to a new application, we should already be there and stable. We talked about assurance a little bit earlier. Who here has to freeze their compiler version? Okay, this is where assurance comes in handy. If you ever have an issue with the compiler and you can't go from, let's say, version 18.2 to version 19 in order to get that fix, having assurance and being able to get a fix on version 18.3 where we didn't change much, we only fixed critical problems, is going to be in your best interest. This happens when, again, you have to freeze a compiler, you're going through certification, whatever reason you have to freeze, this gives you a lot more stability. What's interesting about that is we only fix things that are critical bug fixes. We won't rev the GCC version on you. That's going to cause a big problem. So we're only going to fix critical problems, and we're also going to provide known problem analysis. So when you are going through a certification, you have all the documentation available to say, yes, this is what was changed between this version and this version. It doesn't affect us outside of this one critical fix that we did here. GPS, Nico just did a wonderful presentation on GPS. So if you're using that for Ada, you can use that for C and C++ as well. CLang is embedded within GPS, so you will have everything you're used to in a modern C and C++ editor right in GPS. It does things like smart additions, so it does cross-referencing, navigation, and you can do build and debug from this. It's kind of nice because, again, you have one application. It has all three languages. You should have one build framework. You should be able to click one button. It builds it all together. You should be able to hit run or debug and debug that all from a seamless interface. Anyone who's doing code coverage, we do have a code coverage tool if anyone is interested in that. And we can do code coverage for Ada and C. The way this works, if anyone's not familiar, is that GNAT coverage runs on top of an emulator. Traditional code coverage technologies instrument the code and then run the tests on the code and then use those instruments to reverse the traces and be able to provide coverage. What GNAT coverage does is it actually it instruments the execution environment, runs the application in the executed environment, and then reverses the traces back to code. The difference between those two is with GNAT coverage, you're testing the actual binary you're shipping on a virtualized platform. With the other version, you're testing an instrumented version of the code, which isn't necessarily what you're going to ship. We are working on an instrumentation version of GNAT coverage, so you will have the option to do both of those things. Doing things in a virtualized environment is more like doing things with a JTAG. So as you can see here, this top section is using emulators. This bottom section is using a JTAG or a trace utility. So with the trace utility, we're actually putting a trace on the hardware and reversing things off the trace. So we can do that for Ada and C. GNAT stack, tool to be able to compute worst case stack analysis. You can do that statically. This is for Ada and C. This works for everything except for what we say here, manual things. Like we can't look at system calls because obviously we don't know what's inside the system call. This would be the case where we can't see the actual body of the call. Like let's say you're calling Linux file open. We have no idea what that code looks like because we can't actually see the version of the software you're looking at. So you have to provide some information there. Recursive calls. We can't compute recursive calls because we can't actually compute how long those go, so you have to give some information to that. However, this does give you a good idea of what your worst case stack analysis would be for Ada and C applications. And as we mentioned, this can come with DO 178 qualification material, so you can use that in a certification context. Who's ever ported an application from one NDNS to another NDNS? A lot of work, right? Or, even better, using one NDNS and then all your communication is in a different NDNS. It's a lot of work to be able to handle that. So with the GNAT compiler, with Ada, we have the Pragma scalar storage order, which allows you to specify the memory layout of a specific record, whether it be big endian or little endian. You can do that for C as well, which is pretty cool. So with the GNAT compiler, you can actually specify that this struct has a specific storage order. So if you're ever doing a port from PowerPC to everything else, this is going to be very beneficial to you. I'm not going to go into this so much because we actually have a presentation on this coming up tomorrow, I believe. So hang around for that. Who here has an application like this where you have C++ calls Ada, Ada calls C++, and then something goes wrong in C++. It goes back to Ada and then goes back to C++. That's pretty complex, right? But that's pretty normal. You know, especially if you're calling into a library and then that library is calling another library. So this gets pretty complex, but this is one of the reasons why you might want a consistent version of GCC across your entire platform. The exception ABI changes a lot within GCC. So having different versions of GCC and trying to do exception propagation is nasty. Doing it with the same version of GCC is very nice. So if you do something like this, very much consider using one version of GCC for all your compilers. For those doing mixed language applications, with GPR build, you can build all of it in one step. All you have to do is specify that what languages you're using in the application. So in this case, we have Ada, we have C, we can also add C++ to this. For those that don't necessarily want to use, for those that want to use C and C++ compilers from their system, you can actually configure that GPR build to use other compilers. But using GNAT compilers, it's all integrated. In those mixed applications, you have to have bindings from one language to the other. So typically, you're going to have to do a lot of Pragma imports from C to Ada. So in this case, we have a procedure in Ada. We're importing that from C. Here we have the exact opposite, where we have a procedure in Ada and we're exporting it to C. How many people have done this and messed it up and it was nasty and horrible to work with? Definitely me, yeah. Well, this gets especially bad when you start doing things like records and you have to start sharing data types across boundaries. Especially when you have to talk about convention C, and all those things. And then we have to start doing pass by copies, pass by reference. Unfortunately, C, you can't pass by reference, so you actually have to be cognizant of what you're doing there. With the GNAT compiler, you have access to the binding generator. So what you can do is take a header file that you have available. Let's say you have a header file from a C library. You want to create an Ada binding to it. All you do is you specify GCC fdump Ada spec on that header, and that's going to generate a thin binding, Ada binding, to that header. Now, what you do with that is usually build up a little thicker binding. There's going to be a lot of interfaces .c, .int types, or .char types, or things like that that are very C oriented, and you're going to want to kind of abstract that to be your actual Ada data types. But this gets you a long way. And what's interesting is if you do end up writing your own bindings, which sometimes you want to do, you can actually go from Ada to C and make sure that you actually got the binding correct. So let's say you write a binding in Ada, you can call gcc-gnat CEG, and then that'll generate the C header, and then you can compare that C header against the one you already have to make sure that you actually got the types right. So this is kind of a nice way to debug what you're doing. For anyone who is doing C++ and Ada, you can share object-oriented objects across those two boundaries. So in this case, we have a C++ base type, and we have a derived type in Ada. So this is something that you can do. Ooh, that got cut off. For anyone who has Simulink and is interested in our Simulink generators, this is QGen for anyone who's interested. We have a talk about this coming up, I believe, tomorrow. But with that tool, we can actually take Simulink code and generate Spark or MISRA-C. So this would be a case where, let's say you already have a C compiler, or you have a C compiler that we don't support. If you have a custom DSP or something like that, or even with our C compilers, you can generate C if that's what you want to use. You can also generate Spark with this application. What's nice with QGen is you can take your high-level models like you see here, generate your code, and then do debugging on the target, but actually be debugging at the model level, not necessarily at the code level. So you can be changing coefficients in the model. That will be changing the actual code. You can be doing that with a live processor in the loop debugging. And last but not least, the CCG tool. Quentin mentioned this earlier, the common code generator. The idea behind this tool is not as an Ada to C converter. The idea behind this tool is if you want to write code in Ada and Spark, meaning you want the benefits of Ada and Spark, but you have a platform that we don't necessarily support. Let's take AVR, for instance, or 68K. If you have these applications that we don't have a compiler for, you can generate C code from your Ada and Spark. So you still get the benefits of Ada and Spark. It generates C code, and then you can compile that with your compiler, with the C compiler you already have. This is another application where, let's say you have a DSP, and that DSP is custom. It comes with a custom compiler. We don't support that. You can still write your application in Ada and Spark. You can do all the proofs. You can do all the static analysis, like I mentioned earlier. You can do the CWE risk assessment and all that using all the tools that you have in Ada, and then still use your C compiler at the end of the day. So this is a tool, if you're in that situation, this is a tool that you can consider. Some caveats to this, though. The CCG tool requires that you use constructs in Ada that actually can be converted to C. So if you start thinking about it that way, you think, well, there's a lot of things that can't be converted. Object orientation, for instance. So what we say is in CCG, there are supported constructs and unsupported constructs. If you have legacy code, it might be difficult to use this tool because you might be using things in the runtime that cannot be converted. If you're writing new code, you can consider this. So this is kind of, there is some caveats to using this tool, but it is a solution if you're in a situation where we don't have a compiler off the shelf for you.